So in the test, you're going to have a graph, and you'll see it at least crosses at one integer. Okay, like at -5, you can see that the graph crosses the x-axis, and that's a graph of this polynomial right here. So the reason for doing that is so that you don't have to go use the rational zeros theorem and try to figure out which one of those many rational zeros are an actual zero. It's a starting point. And we know that -5 is going to be 0, so watch carefully. That means that this function can be rewritten as x plus 5 and then times something else here in this parentheses. Okay, we have to do a little math to figure out what goes in that parentheses, but do you see why I put x plus 5? Because if -5 is going to make it equal 0, then I should be able to plug in -5 into one of the factored components, and it should also make the whole thing be 0. So -5 plus 5 makes 0. That's why I didn't do x minus 5. So what goes here? Well, that's the leftover when we take this and divide it into this with synthetic division. Okay, so let's conduct our synthetic division. We put the root of the divisor up here, copy down the coefficients, so those numbers in front of all those terms. And when you're done, if you've done this correctly, you should get no remainder, right? So we carry down that 1, and then we do -5 times 1 makes -5, then we add the columns. -5 times 0 makes 0, and then we add the columns. -5 times -3 makes 15, and then we add the columns. So no remainder, just like we expected. Remember the last part of synthetic division, you start with x to the third, you divide by x to the first power, so you've got x squared as your new highest power. And then plus 0x minus 3. Okay, so we found out -5 was a root from our graph. That let us know that this is definitely going to be, this is definitely able to divide into this polynomial without a remainder. So we took this and we rewrote it like this. And look, if you were to multiply this out, you'd get this again. Okay, so we just restructured it. And the reason why this helps is because just like with quadratics, you set each factored piece equal to 0, right? We already know what this one's going to yield. This is going to give us x equals -5. And then when we set this factored piece equal to 0, you can add 3 to both sides. And then use a square root to cancel out a squared. And every time we do that in math, we got to remember that the positive or the negative answer are possible. So there's our other two zeros. There's 3 total. Here's x equals -5 is one of the 0. Square root of 3 is one of the 0. And negative square root of 3 is another one of the 0. So looks like D is the correct answer.